And one quick disclaimer before we start, the government does not endorse products or companies, so nothing in this is an endorsement. If you see any resemblance to any products that you may know of, that's coincidental, totally fictional.
So, hi, I'm James.
And my name is Andy Brody, and we're here to talk to you about time travel.
Before we get into the actual time travel, I want to talk a little bit about who the U.S. Digital Service is. Yeah. Forgot I had the clicker. So many of you probably heard of the healthcare.gov fiasco a few years ago, where it did not work at all after government had spent many hundreds of millions of dollars. What many of you may not know is a small team of about 6 technologists from the private sector came in a matter of months, actually got it working. Before that, Obama and his administration had been thinking, we need to probably get some more technology people in government. When they saw how much a small empowered team could do, they went, we really need to get technology people in government. So that was kind of the catalyst for creating the digital service. We're currently about 170 technologists. We're engineers, product managers, designers, procurement specialists, bureaucracy busters, and others.
We serve tours of duty in the federal government, ranging from 6 months to 4 years.
So we work as kind of small cross-functional teams. We work across many different agencies in the government with many different populations, from Medicaid recipients to veterans to immigrants and asylum seekers and many others.
So James, how has it been working for the government after the change in administration?
Well, first, we're still here. After the election, there was a lot of question of whether USDS could even survive the change in administration, which we did, so there's a win.
Happy birthday to us.
But as it turns out, this administration, I'm guessing probably most administrations in the future, they actually like improving services for the American people. They want the government to be better. So we've continued to have support from this administration. And really in our day-to-day, it hasn't changed much. We're still working on many of the same projects we were previously. We still do work in the same way. We still get many more requests for us to help out on projects than we can actually staff.
That all sounds great. What's the catch?
The bureaucracy. Do I really need to say more than that? Okay, a little more. So the government, as we all know, has a huge bureaucracy. And it has a lot of inertia behind it to keep things the way they are. At its heart, USDS is a change agent. We're basically coming into government and saying, there's a better way to do this. Let us help you. So we're doing a lot of pushing against that bureaucracy. And I'm not going to lie, it can get tiring at times. We'll even hear things like people tell us, you know what, it's illegal to use cloud services. You can't do that. And we literally have to go find the legislation that they think makes it illegal and bring it and show them that, no, it's actually not illegal. There's special requirements or whatever, but you can actually use these things.
So a straw poll for you all. When we had to spin up one single VM in an agency's so-called private cloud, how long do you think it took? Raise your hand if you think it took 1 hour. Now, an hour is, it's a pretty long time. All right, 1 vote. That's, it's optimistic, but that's still a pretty long time. How many of you think it took 1 month? All right, good number of people. How about 6 months? Good number of guesses. A whole year. And for the real pessimists in the room, who thinks it's still not done? A lot of pessimists. All right. Took us 6 months.
That's just insane. Why would it take 6 months to get a single VM?
Yeah, and just to put that in context, that means if we start today, our new VM will be ready sometime in the fall. September, October, check back, we might have a server for you. So just to make it a little more concrete, this is a partial list of the steps that were required. I'm not going to go through this, but let's just say it involved a lot of Word docs emailed around and tickets filed in more than one ticketing system. Oh, and this all cost 10 to 20 times what it would cost in kind of a public cloud service vendor. So working on technology in the government can feel like going back in a time warp 10 or 15 years. you look around and things feel kind of strange, but they start to make more sense if you think of it like someone trying to follow last decade's best practices. Now, don't get me wrong, 1999 was a great year in technology, just we've come a long way since then. And that 6-month time frame for launching a VM is really just the tip of the iceberg. Many government agencies deal with technical debt going back decades. You think your tech debt is bad? Most of these diagrams come from actual government technology policies. This is expert level chart junk. And stepping back in our time machine, you're lucky if your server isn't a literal mainframe. Enterprise Java Beans are the container platform of choice. And the beating heart of many agencies' operations is what's called an enterprise service bus. Now, if you've never seen an enterprise service bus, just imagine a giant opaque ball of spaghetti that all your requests have to go through. This was supposed to make it easier to connect siloed services. So it's a queue, but it can also run code, and it connects directly to your database, which seemed like a good idea at the time.
So I have an idea on how we can fix the mainframes. We'll just go straight to this whole serverless architecture I've been hearing about.
Yeah, so it's tempting to think that you can fix this just by introducing the latest buzzword technology.
So if we can't do serverless, how about we use blockchain to fix all the healthcare records?
Do not do that. Do not. Blockchain will not help. And more to the point, bad tech is often a symptom, not the cause of dysfunction. We like to say that there are 3 things that are super hard in the government: hiring, firing, and buying. And the trickiest part is that these are all hard for good reason.
So hiring. A normal company, if there's a poor hire, worst case, they might lose some profit, could go bankrupt. In the government, if there's a poor hire, it's the American people that suffer from it. And as we'll discuss in a few seconds here, it's also really hard to fire somebody in the government, so if you make that poor hire, you're stuck with them. There's some other challenges, like government salaries are very structured and capped. This is to avoid favoritism, nepotism, and things like that, but also means high performers don't get rewarded. Government also doesn't have stock options. And finally, there's a lot of paperwork to try to get hired on in the government, and I mean a lot of paperwork. It will take many months and many hours to kind of go through the process. I will say USDS, we simplify it, it's much quicker for us, but normal government, it's a long process. Firing. One of the challenges in government is it can actually be hard to measure performance because most government services are monopoly. No matter how bad they are, people still have to use them. No matter how good they are, the same people are going to be using them. So you can't use a lot of the kind of common metrics of, oh, we've increased our customer base, to figure out whether this was good or not. There's also a large bureaucracy, so people kind of making decisions are disconnected from the end result, so there's a lot of wiggle room to say, well, that wasn't my fault, it was theirs. There's also a lot of political protections for civil servants to make sure they don't get fired for their political beliefs.
Yeah, many people don't realize that only the top 4,000 positions in the executive branch are political appointees. The remaining millions of government workers are career civil servants who serve under many presidents.
There's also whistleblower protections. For some, there's union rules and many other kind of protections. There's also a lot of paperwork that have to go through to fire somebody, which does dissuade people because it's a lot of work again. Now, all these things are there for good reason. We want to protect the civil servants. We don't want them to be fired for their political beliefs. But when you add all of that on top of the bureaucracy, it makes firing somebody really, really difficult.
So let's talk about buying. The government spends public funds, which are easily abused if there aren't safeguards. I'm sure Joe's thrones are very comfortable, but we don't need $1 million chair for every government employee. And so as a result, the US has a complex process for running open competitions when buying anything, and special teams of contract officers who act with independence to guard against corruption. But these contracting officers typically have no technology experience. They might go from buying furniture one day to awarding billion-dollar contracts for software services the next.
And that's actually the same way they buy a helicopter or a battleship.
Same thing as software, pretty much the same thing.
So kind of an example of how those challenges manifest is, let's kind of talk about a typical government launch. And as the slide says, healthcare.gov is more the norm than the difference. So most government launches are planned years in advance, involve hundreds of people and mountains of paperwork. Now, a lot of that's because of how they can actually procure or hire contract teams to do the work. It's the traditional waterfall method where they have to give everything up front and the contractor has to build exactly what's in that contract.
Most agencies think of it like building a car. The idea is that if you spend enough time up front, you can create the entire design anticipating any problems and release when it's perfect. Beta testing, soft launches, and iterating after launch are generally unheard of. Once it leaves the factory, it's done. Get a new piece of software 20 years from now.
So let's talk about a specific launch. The Trusted Traveler application, which is part of Customs and Border Protection for global entry so you can get through the customs at the airport quicker. And it was integrated with Login.gov. I was the US Digital Service team lead for the Trusted Traveler project.
And I lead the infrastructure team for a site called Login.gov. So let's face it, government login systems suck. And there are thousands of them. The login system for healthcare.gov alone cost $100 million and caused 70% of the first year's downtime. Just let that sink in. Worse still, many agencies don't offer services online at all because identity proofing is so hard. For example, the IRS last year announced a big contract to Equifax, yes, that Equifax, after the Equifax breach was announced, and then had to fend off a lawsuit from Equifax when they moved to cancel it. So this is a real government website.
My favorite part is if you look closely under at the bottom, there's a text-only link. So you can disable the images if you want.
It's a thing of beauty. Here's another. You'd need a microscope to use this from your phone. Now imagine if you could log into any government website with a single set of credentials using a system that is secure and modern and works on any device. Now this is Login.gov. Login.gov is a joint project between USDS and 18F, which is a similar tech startup that's embedded within the General Services Administration. And because Login.gov was built from the ground up by USDS and 18F engineers, we've used modern practices from day one. The Login.gov team operates really like a startup within the government. The app is hosted on cloud infrastructure, where we light up VMs in minutes or seconds, not months. It's all configured with infrastructure as code, and the team is a cross-functional group that works iteratively to develop features and release them. And the main app is open source. Find a bug, send us PR. This is really groundbreaking for critical government infrastructure. So the first major site using Login.gov was the new Trusted Traveler Program website.
So one thing many people don't realize is travel, so going through TSA security at the airport, going through the customs when you come back in the country, is actually the most common way people interact with the federal government. And if that's a bad experience, it actually degrades people's confidence in the government for other services as well. So the Trusted Traveler programs like TSA PreCheck and CBP Global Entry, basically the member goes through a background check, and then assuming they pass the background check, they get to go through security quicker. So it creates a more secure process and a better experience for the traveler. So it's a win-win. Now, this was the old CBP Trusted Traveler website. It's hard to even tell what this website's supposed to be for, other than it's supposedly a government website, and let alone figuring out where you would go on this site to sign up. It was actually so bad, people would come to this site, not trust it, go to a third-party site, and pay them to sign up for these programs. So we spent about 9 months working with Customs and Border Protection. We did everything from kind of low-level technical coding to system architecture to a lot of process and culture changes. Two kind of big areas that we really focused on was the CI/CD pipeline. So this was the first application CBP was ever moving to the cloud. So all this was kind of brand new to them. Another item was the real-time monitoring and metrics. That's just not common in government to have. They, it's not included in the projects. They don't even necessarily see the value of it. So we get to the launch. We do a phased launch. Yeah, sort of. So because we were making so many changes, we were really pushing for a phased launch. But as we mentioned, governments, usually the big bang launch, that's how they do things, that's what they know. Because of all the government kind of processes and the other systems that were linked to the Trusted Traveler, in the end, we couldn't do the phased launch we wanted. We did get an internal-only launch, though. But it turns out there was problems accessing it off of the internal network. So we had about 15 people go through that process. We actually did find one or two things, but wasn't too helpful. So this is the new Trusted Traveler website. So it's hopefully much easier to understand, much easier to know, where you can go to sign up. It's also responsive, so when you're waiting in line at the airport going, why are they going faster? You can actually start filling out your application right there. So the launch happened on a Sunday because it was going to have about 8 hours of downtime. And so you can see kind of the chart on the, I guess would be left. The green line is the 200 response codes when we turn the site on live a little bit after noon. Then the kind of multicolored chart is each color represents a different step that they made it through in the application. So we could see they're making it through the whole application. Been live for a few hours, everything was going good, team was happy. I was feeling a little nervous because things had gone too well and we had changed too many things for it to actually go this smoothly.
And during the same time, I was poking around the site, looking for bugs, seeing if I could break anything. So I found a thing. Let's just call it a no good, very bad bug.
Yeah. So I'm at Punteney. And so that was the message from Andy over Slack. Just what I wanted to see on launch day, of course. So worked with CBP. We actually got the site offline in about 10 minutes, which I think is probably a government record. Once it was offline, we then had some time to figure out how we were going to fix this bug. So we worked with the engineering team to figure out how we were going to fix it. Then while they were actually fixing the bug, myself and another USDSer actually went through the logs line by line. We had set up with an elk stack for aggregating the logs to ensure nobody had taken advantage of the vulnerability. Luckily, Andy was the only one who had. So then about a little after 11, so Sunday night, a little after 11, got everything fixed, turned the site back on, monitored it for a couple more hours. Everything seemed to be going well.
Crisis averted, all systems nominal. We all went to sleep with not a care in the world. So the next morning, I was woken up by PagerDuty, my favorite alarm clock. This is what Login.gov looked like. Not so good. So we scaled 400 times the day of launch, and a lot went wrong. This chart really tells the whole story. So prior to launch on the left, you can see that we didn't have that much traffic, not much appreciable traffic beforehand. And then you can see the spike on Sunday where there's, a big jump, and we thought that that was kind of what we were going to be seeing the whole time. But that really wasn't that much compared to what was to come. So our first problem, we had recently moved to kind of an auto-scaled infrastructure, which is great for horizontally scaling. But we had forgotten to set minimum counts for the number of instances. So you can see that little red uptick just before the discontinuity. As soon as health checks started failing, our systems naturally concluded that everything was unhealthy and terminated them all. So you can follow the roller coaster as it went up. Then we accidentally terminated all our instances. But once we spun up more capacity, it handled the load pretty well. And quadrupling our capacity in a matter of minutes was a huge win just by itself. Remember, this is against a backdrop where months to spin up or a server is normal. But we weren't out of the woods yet. So problem number 2, now that our servers could access the site, we had to be sure that our third-party services could actually handle the traffic. We were trying to send email and SMS verification codes way faster than our rate limits, which led to huge queue backlogs. Fortunately, we already had good relationships with our messaging partners, so getting our rate limits raised wasn't too bad. Once we realized this was happening, we'd spent a little more time because AOL, for some reason, was rejecting all of our traffic or sending it straight to spam. So that also took some time to resolve. To diagnose that, I ended up creating a brand new AOL account in 2017. And yes, they still do the "you've got mail" thing. I've never been so glad to hear those words. Problem number 3. So a Heisenberg bug, as many of us have experienced, is a bug that seems to disappear when you try to isolate it. Oops, something went wrong. The site was up, but people were seeing an awful lot of this page. Not a very helpful error message either. And this was odd because our error rate was clean. There were no 500 errors in our logs or graphs. But we knew something was seriously wrong because our login success rate metric, which is our most important metric, was hovering around 20%. Didn't seem very good. And we noticed a lot of CSRF errors in the logs, which was very strange. That's not a normal thing. So to understand this, we have to talk a little bit about the way that Login.gov does encryption. So Login.gov uses a unique scheme for storing sensitive data, where user data is encrypted with the user's password. And this provides a super strong privacy guarantee because even Login.gov internally can't access your stored data unless you've recently provided your password. And especially, for people accessing government websites, this is a nice guarantee. But when you first sign up, we need to track session data before you've set a password. So the application generates a random key to use for the session data. And now the fatal problem, that random session key is unique per Ruby process. So you can probably see where this is going. So this was all obvious in retrospect, but we had papered over the problem by enabling session stickiness. And a third-party library the app uses was silently swallowing the decryption failures with a blanket rescue statement. So you think about linting your own code for bad practices like this, but really we should have been linting our dependencies as well. And because of the way our process dispatcher works, if server load was light enough to be handled by a single process, you would always return to the same process on that server and never see an error. So this only manifested reliably once there was enough load to cause requests to be handled by many different processes. So having identified this, we did some wacky stuff to work around it. Changing crypto code in the middle of an outage didn't seem like a good idea. So we ended up spinning up 50 very small app instances, each running a single Ruby process, and then relying on that session stickiness to route them all to back to the same server. So that got things working and bought us enough time to fix the problem by light of day. And our login success rate shot way up.
All right, success. Finally, all the users can actually log in. They can sign up for their travel benefits. By our own admission and looking at, we felt this launch was not very good. It was pretty rough. But for the agencies, this was actually one of the most successful launches they'd ever had. Congratulations were coming in left and right on the successful launch, and we were kind of going, what? And while we would have preferred a much smoother launch, in some ways the kind of bumps and issues we hit were beneficial. Is it quickly showed the benefit of all the systems we were putting in place and we were pushing for the agencies to do. The real-time monitoring let us see the errors right away, the aggregated logs. We could check to make sure the vulnerability wasn't taken advantage of. And we could, sorry. Where am I at? So yeah, because of the faults, the agencies actually saw the values of all those processes. Where before that, they're kind of going, yeah, sounds good, whatever. But it actually demonstrated why you need these things. I also want to give a lot of credit to CBP and GSA. They were willing to take on this challenge, to change their processes, try to do this a better way. And even when things were going wrong, they continued to focus on the problem and work together to solve it. They didn't go to the blame game, which is very common in government. So, how did we get there? Well, with the digital service, we've made a playbook. It's got kind of our 13 best practices or plays for kind of how we can engage to help modernize these services. We made a website for it. You can go to playbook.cio.gov to see it. The first 6 plays you can see here. Looking at them, you might go, these seem pretty basic and normal. Understand what people need. Of course. But again, in government, because the large bureaucracy and hierarchy, a lot of times the people building the system have absolutely no contact or minimal knowledge of people actually using the system. So getting that is actually a huge step for government. Assign one leader and hold that person accountable. In government, that's actually problematic for 2 reasons. One, government works by committee. They don't say one person go do this. They get a committee of 20 people to go and do this. Then even if they do assign one person, as we talked about earlier, actually holding that person accountable is pretty hard.
So you might be noticing that most of these are very loosely about the technology. Only these 3 of all 13 are really focused on the tech. And in many ways, the hardest problems are all about process and organization. So Mikey Dickerson, the first head of USDS, developed this idea of a Maslow's hierarchy of needs for SRE. If you don't know whether your site is up, nothing else matters. So put monitoring as the foundation. This type of thinking really helps us prioritize in an environment where there are unlimited things to fix. The pyramid is very intuitive. You might have seen it in the Google SRE book, but it's especially powerful in organizations that are just starting on their SRE journey. So after this launch, we naturally wrote up a lot of postmortem action items. Remember that the government has a scapegoat culture where Congress fires the head of an agency when things go wrong. Like people are afraid of literally going to prison. So building a culture on our projects where failures are celebrated as learning experiences is a huge part of being able to deliver working services. And obviously, the first lesson here is don't do a big bang launch if you can help it. But if you must, establish shared monitoring, incident response process, and fast channels of communication across silos. Those were a lot of things that really enabled us to be successful here. Load tests, dry runs, and dark launches can all mitigate risk, but they're no substitute for being able to move fast in production when the main event arrives.
So how do things stand now? Well, for Trust Traveler, in the first 30 days of production, they had 50 pushes. No downtime with any of those pushes. Now, for many of you here, that probably doesn't sound that impressive. For government, that often does 2 pushes a year and schedules 8 hours of downtime for each of those pushes. This is downright magical. They didn't know it was even possible. There's been over 500,000 completed applications, and the team's addicted to the real-time metrics and dashboards. This is just something they've never had before. They didn't even know it was possible.
This chart shows Login.gov's user growth over the past year, up and to the right. Last month, USA Jobs started using Login.gov. That means that anyone who applies for a job in the federal government now uses Login.gov to sign in. Previously, USA Jobs had security questions and no 2-factor authentication. Now they've got a much more modern system.
So this movement's just getting started. There's tons of public services that are ripe for improvement. There's many leaders and teams throughout the government that want to move to these new technologies and new processes. They just don't know how to get there. USDS brings people like you into the government to help them move forward with their technology. Today, USDS is almost 200 technologists, and here's a few of the things we're working on.
We're making it possible for Medicare to pay for quality of care, not just quantity.
For those of you that saw Aaron's talk yesterday, you got to see some of the ways we're helping veterans get the care and services that they've earned.
Our team at the Pentagon ran the government's first public bug bounty programs, which more and more agencies are embracing to improve security.
And we're making the U.S. immigration system faster and simpler to navigate for new Americans. These are just a few of the many projects that we're working on across the the USDS.
Thank you.